Okay. So where do you host Jenkins on EC2 machine? What you are doing? You are building application using pipelines, right? But to build an application, you must download the source code, okay? And you need to build it using some tool like Maven, Gradle, or anything, right? So where do you build those? Where do you check out? Where do you build, right? So you are checking out and building on some agents, right? You might have used agents here. Anything try? Anybody try to speak? I Okay. So agents. So 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 can anybody tell me if you have seen this concept called agents on Jenkins? Anyone? So have you used Jenkins? Uh, so you have seen Jenkins in the last few sessions. So have you got chance to check what is agents, or where do Jenkins check out your code, and where do you do it build your application? Because to build your application you need a source code on your system, you need the Maven plugin or Maven command on your system, you need AWS to push your application to AWS services. Okay, so all this thing must be installed somewhere, right? So they are called agents. So agents are core into the core part of Jenkins infrastructure. They are like, it's a master slave architecture. So slaves are often called as agents for Jenkins. So they are connected to Jenkins in some way. Okay, so they can be VM, they can be physical machines. Okay, they can be physical machines, or they can be containers. Okay, so we'll talk how can you use containers for container as agents in Jenkins. Okay, so building is fine. Now how do you so once your build is done, how do you test it, right? Again, you can use same thing in Jenkins. Just like Jenkins, you do a sonar cube test, you will do a static analysis, you run regression test, you do selenium test. All these things can be done using Jenkins. But how and now where do you deploy it? Okay, you deploy it on EC2 machine. Okay, maybe EC2 machine or S3. If it is a static website, you deploy on S3 machine, S3 bucket. Okay, you deploy on Lambda. Okay, so if you have a microservice that can be run on Lambda, you use Lambda there. Okay, or they can run on some advanced platform like Kubernetes. Okay, or they can run on some container environment like Fargate or ECS. Okay, so these are the ways you can these are the platform where you can deploy your application. Okay, uh, uh, so all these things like these deployment thing, right? Okay, so so the last two part, okay, they are not VMs. Okay, they are not VM, they are container based platform. Okay, Kubernetes is a container orchestration platform. Fargate is a container platform. ECS is again a container platform. Okay, so you see, so these are the flagship platform where most of the companies are migrating to deploy their application because they provide some real good features on top of EC2 machines. Okay, so if you deploy on EC2 machine, your cost will be based on one machine here. Okay, so we'll see uh, how you can use Kubernetes and Fargate. Basically we will focus on Kubernetes only, not Fargate or ECS. So because that is a major tool used in DevOps lifecycle. Okay, and again, like so these so you see in testing, in build, right, in deployment, and also in monitor and alerting, you will use container all the time. Okay, so because container are core to the DevOps, like they give you a consistent environment, and we'll see how they provide you consistent environment. Okay, so um, so next few sessions we'll talk about container technologies and how to use them. And two major technologies we will cover is, one is Docker, okay, and another is Kubernetes. So we will talk about how to use Docker, how to install it, and how to run Docker containers in your on any system. Okay. Um, we'll also see how to manage containers using Kubernetes. So Kubernetes a is a like is a big platform where you can manage containers in a better way. Like it provides you high availability, load balancing, um, and it also provide you fault tolerant, uh, healing capability. All those things is part of it. So we will learn about Docker. Okay, Docker as a container platform, and Kubernetes as a container orchestrator. Okay. So Docker, Docker, we will learn about, using Docker desktop, and there is another way we can learn Docker is play with Docker. This is a platform. This is a online free platform where you can play with Docker containers. Okay, it provides you a UI, a graphic, a CLI where you can run Docker commands and you can deploy containers there as well. Okay, basic commands, hands-on. We will take two hands-on here. Okay, and same goes with Kubernetes. We will learn the basics of basic architecture, how to set up a Kubernetes cluster, okay, and how to use the basic objects like pod deployment services, and we'll also see how to use secrets and config map. Okay. Okay, so let's talk about Docker. Okay, so anyone of you have experience in Docker before? Anyone of you? Have you anyone of you worked with Docker containers or have heard of uh, 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 these tools in any of your work
Uh,
uh, environment? Yep,
like basics.
basics. Okay. So where do you did you use it or you have just heard of these?
Like I've learned about it, I've heard about it, but usage is very limited. Only few things I have done, like not set up, but
Mhm.
only creating containers and only the basic things.
Okay. Yeah. Sure. So so we'll cover a few we'll cover few things here, and then I'm 100% sure you will be very comfortable with Docker container technologies after this sessions. Okay, so let's uh let's see. Okay, okay. So what is Docker, right? So if I talk about the history of computers, right? Um, so how many of you have used computers in 1995? How many of you have you watched Rosa, the Rosa movie? Right? Have you seen that movie? That was the first movie that was picturing computers in the television. So like so it's a movie that talks about email, how email flows like from one person to another person, and it was the starting of the internet era. So it shows you how the starting of how the initial era of internet was. Uh, how does it look like in the initial phase of computer um, in India? So if you haven't watched it, you can go and watch it. It's a wonderful movie. Um, so mainly revolve around how people use computers in the initial days. Like if I go back to like 20 years back. So if I go 20 years back, okay, 20 years back, right? 20 years back. Okay. So all of us are 20 years or more, right? So if I count the age of people in the class, most of you will be 25 plus. Like no offense, I don't want to get offense if everybody. Some of you are 21 or 24. Uh, well, okay. So most of us have used Windows XP, right? Okay. When you use Windows XP, what challenges you used to face? So RAM, right? Memory, memory limit. Uh, so you might have used Windows XP, and you see a lot of memory issues. Like I cannot play two games. I cannot have multiple application running on the same machine, right? You cannot run. You can only run one operating system, right? Windows only, right? So RAM was an issue. Multiple application lags, right? Lags, right? I'm talking about Windows XP era, right? So here, we RAM was an issue because you cannot have unlimited RAM, right? You cannot have unlimited RAM. No unlimited RAM. RAM was limited, right? RAM was limited, like 2 GB at most. At most, if you're a like rich guy, if you were used to be a rich guy, you would have like 4 gigs of RAM. I used to have 500 MB RAM. Like I was that old. Okay, so RAM was limited. If I open two application at a time, like the other application will die. That issue I faced, right? So multiple apps will lag. So that was an issue. Okay. Third issue is I wanted to learn Linux, right? I was a guy, I was learning at that time, and I had this thing, right? I wanted to learn Linux, okay, but I cannot go away from Windows XP, right? I cannot say that I can directly shift to Linux, okay, by installing Linux on the system and just get away from Windows XP. That was not a easy thing to do, right? Because if you're learning Linux, you cannot discard the old operating system that you are comfortable with. So cannot can't try any new OS. Okay, so that was one of the challenge, right? Okay, and there are other challenges as well. Maybe disk space, and we are not talking about that. Okay, so this was a challenge when uh, in the initial era, right? So after 10 years, like, okay, this is the time when I graduated from college. Okay. So one challenge was I when I graduated from college, Windows 7 was on the boom. Okay. Uh, so one challenge was how do I try Linux? So okay. So RAM was not a concern. Okay, because Windows 7 supported like 16 gigs of RAM. You can even run 32 gigs of RAM. If you have money, you can install 32 gigs of RAM. Okay, I managed with 8 GB of RAM, which is fine. RAM was enough. Okay, I had enough RAM. Okay, so the second thing is how do I run multiple apps? Because I had enough RAM, I can run multiple apps. Okay, but again limited to the OS support. Okay, so I cannot run an application that runs on Mac machine on my Windows machine, right? If I pick a Mac, if there is a application that runs only on Mac machine or only on Linux machine, that I cannot run on my operating system or my Windows machine. Okay, so I can only run those applications which are supported by my operating system. Okay, so can run multiple app, but again only apps only supported by the installed OS. Okay, perfect. So the fourth one, like cannot try an old new operating system. I can try a new operating system if you're a guy older than me or even like near me. So you might have heard of VirtualBox, right? How many of you have heard of VirtualBox? I am sure most of you. How many of you have heard of VirtualBox?
Yeah, what about?
Yes,
I've used VirtualBox.
Yeah, we have used VMware once.
VMware. Okay, VMware. Yeah, I like that product, VMware. VMware Workstation. Yeah, my favorite. Any other like other people, have you used VirtualBox or VMware Workstation?
Yes.
Okay, Anuradha have used it. Great. So Anuradha, can you just tell me uh, for what purpose you have used VirtualBox or VMware Workstation?
I think it was a part of our semester syllabus. Like that time we had used that one.
Great. Yeah, so that was okay. I use it for the same purpose. And then after the course was introduced in the semester, I was in love with these tools. Okay, so these tools are called hypervisors. Okay, so what are hypervisors? So hypervisors help you to run another OS on top of one OS. Like you have one OS installed, and you can run any other OS on that machine. And the communication, the communication and the channels are provided by hypervisors. So when you install VirtualBox and VMware Workstation, you can install any new operating system, but just by selecting the disk. Okay, so you can download the operating system disk on your system. Okay, you install these tools, and then you select to how many GB you want to use for that of new OS, how many CPU, how many RAM, how many disk. All these things you can provide in the console. Like they provide you some UI interface where you can select all these things. Okay, perfect. You can run another OS on top of Windows 7. Like if I use, so hypervisors provide, these are hypervisors provides you ability to run multiple type of operating system. Okay, like run Ubuntu on Windows 7. Okay, maybe like Mac OS, like Mac OS. I never got success of running Mac OS on Windows. Okay, or just for example, Mac OS on Windows. Okay, so that was a dream of mine, but I never got success there. Okay, so I never got success in installing macOS on Windows 7. There were few people who were able to do it, but not I was not that kind of guy. Okay, so hypervisor help you to run multiple type of OS on the base OS. So there's a base operating system like Windows 7, or maybe you have Linux. So you install Linux, and on top of you install a hypervisor. Hypervisor can be VirtualBox or VMware Workstation, and you can install another operating system there. And if you wanted to learn Linux, right, you can install Linux distribution like Ubuntu, CentOS, RHEL, SLES, all these things. And then you can play with Linux command. Okay, perfect. So these are hypervisors. Okay, but again, like these hypervisors, you have to install separately, right? So these hypervisors are L2 hypervisor. So they are called L2 hypervisor. Okay, so if I open this diagram, hypervisors. Okay, pardon me for my spelling. Okay, so if you see this, right, this virtual machine. Okay, so in the left, so you have infrastructure as in like your laptop, or maybe a work a desktop. You have like PC, right? On top of PC you install a hypervisor. Okay, and on hypervisor you install guest OSs, right? The guest OS is the second OS that you want to install it, right? And then on the operating system you install your application, whichever application you want to run. Okay, and then you can access them. So maybe you have one website that only runs or you have a video game that only runs on Linux. So you install Linux as a guest OS, and then run play that game on the guest OS. Okay, so don't need to wait for we don't need to install that Linux machine on the physical machine. You can install it using a hypervisor. Okay, and there are different type of hypervisor. Okay, so if you see here, there is a type 1 hypervisor, and there is a type 2 hypervisor. So type 1 hypervisor, you don't have a OS. Okay, just like we had a Windows 7, and on top of that we installed VirtualBox, and then we installed guest OS, right? Here we don't have a OS operating system. We don't have operating system in Windows. So hypervisor act as an operating system. Okay, and one of the example, okay, is ESXi. Okay, so there's a hypervisor called ESXi. Okay, VMware. So it is a VMware provided hypervisor that that is a L1 hypervisor. So it's a complete operating system based on Linux that you install on a bare metal. So bare metal is nothing but a empty computer. So you buy a hard disk, you buy a CPU, that is a box. Okay, just a box. So you buy a box and you install a hypervisor on it. So the box is called bare metal. Okay, So, and on bare metal, you install a operating system, and that operating system is your hypervisor. And that hypervisor act as a L1 hypervisor. You don't need any supporting operating system for that. Okay. There are type 2 hypervisor, which is like VirtualBox, VMware. You install them as a software on a operating system and then use it for a gas storage. Okay. So there are two type of hypervisor. This is like 10 years back. So when I graduated from my college. Okay, so that is hypervisor. Now, if you talk about the new era, okay, so new era, right? I'll say current. Okay, so this is current year. So, or I would say current minus 5 years back. Okay, since 5 years. Okay, so RAM is not a problem. Okay, so you can buy a system which have 32 gigs of RAM. Okay, even you can extend them. Was not a problem. Was no case. Okay, not limited. RAM is not limited. Is not limited. You can install as many RAM slot. So you have, if you have a laptop, you get a two slot laptop, and you can install 16 gigs in both. You get a 32 GB. If you install 32 in one, okay, and another 32 on second, you get a 64 gigs of RAM, right? And I don't think you will be if a 64 gigs is something you can exhaust on your own, right? You need a that is a very powerful system. A 64 gigs laptop is way powerful, right? So RAM is not a problem nowadays, right? You can install as many gigs of RAM on your system. Okay, uh, you can run multiple apps, right? Nowadays, if you see, right, you're opening so many application on your system, right? So you're running WhatsApp, you're running you're running multiple browsers, right? I see people use Firefox, people use Chrome, people use Brave. Brave is another kind of fire browser, right? You don't need to think about if I need to install this application or not. Will it affect my system or not? Will I be able to open this application? You might be running multiple games, right? You're playing NFS, and side by side you are also watching a movie or something you can do, right? Or your WhatsApp is also running at the background. You receive notification of WhatsApp, right? So WhatsApp is also running at the background. So how's this possible? This is because your operating system is capable of running multiple applications, right? So now you are able to run multiple applications. But there is one problem. Okay, so can you run multiple WhatsApp on the same system? Can you install two WhatsApp on your laptop?
More or less.
Sorry, Sandeep, you said
No,
something.
you cannot install multiple sorts of applications.
Okay. So same type of application, you cannot install multiple same type of application on your system, right? It is possible on your mobile. You can install like dual apps. That is also possible, and that is a different concept. We are not talking about that. On a PC, if you try to install WhatsApp again, you will say it is already installed. So you don't have option to install it multiple more, right? Let's say you have you wanted to deploy a website, right? And uh, you wanted to run two website, okay, and on same port. That is also not possible for you, right? So you have limited resource on the like app side, on the port networking side. So you only have certain number of ports that you can use, right? So if you try to you can install multiple website, that is not an issue, but you have limited ports. Okay, you have your system, like you are working on Windows 7, right? If you install multiple application like without any second thought, after some time your system will start getting slow, like getting slower, right? How many of you have noticed that after installing multiple application, your Windows system is started to get slower? How many of like so? So all these issues, like, right, lamb was limited, so all these are solved nowadays. Okay, but the main problem nowadays, like, we were able to install multiple OSs. Okay, but these OSs consume a lot of the hypervisor, the guest OS on hypervisor is using a lot of resource. Okay, so if you are spinning up a operating system, okay, okay, that will consume some RAM, right? Fixed RAM. Let's say if you give 1 GB RAM, okay, and let's say 50 GB of hard disk, okay, okay. So you are giving this much into to one VM. Okay, VM is nothing but your guest OS. Okay, guest OS. Virtual machine is your guest OS. So you are giving 1 GB RAM to it and 50 GB hard disk to it. Okay, so when you do this, your 1 GB is gone. You cannot use this again. Okay, your 50 GB is gone, so you cannot use this 50 GB for any other purpose. Okay, so that is allocated to your operating system. You cannot reclaim that. Okay, so how many VMs you can install? So if you have like 16 gigs of RAM, okay, so you need at least half, 50% for your host OS. Okay, you have guest OS and then host OS. So 50%. So you're left with 8 gigs of RAM. Okay, gigs of RAM. Okay, and let's say 100 GB, 100 gigs of, or let's say 500 gigs for GBs of HDD for your gas devices, right? So you can run at least at most eight virtual machines on your system. Okay, that means like you can run eight kind of application on your system. Okay, so this is fine. Like if you're running a small company, you can manage to run application on VMs. Okay, so VM give you a lot of ability, and they are still a popular choice among companies to deploy their applications. Okay, so let's say you have a website, and now you want to run website in 10 different machines. So you deploy them using virtual machines. Okay, you deploy 10 virtual machine on a bigger system, and now you have 10 websites running in 10 different environment. Okay, so that way you can deploy 10 application, but that is good if you have small company. Okay, if you go to a bigger company like Amazon or Flipkart, they are not using virtual machines. Okay, they are not using virtual machine because their hardwares are limited. Okay, and they know that if we start creating virtual machine, at some point we will get out of space. Okay, we will get out of resources, we will get out of space, and managing virtual machines is a tough task, to be frank. Like, I have used virtual machine for my 9 years of 9 years in industry, and they are good for some purpose, but they it is very hard to manage them. Okay, if one of the machine goes out, you have to recreate, and recreating a virtual machine take a lot of effort. Okay, and then you have to reconfigure them, you have to install packages on them, right? So all these things are are handy. Okay, so to fix that, okay, to fix that, people came with a concept called containers. Okay, so what are containers? Okay, containers are similar to virtual machine. Okay, but they are very lightweight. Okay, and they don't need dedicated dedicated memory or hard disk. Okay, so what does this mean? They can share memory and disk space with other space with other containers. Okay, slash host. Yep. So containers are just like application. Okay, but they are so applications, like you are running application, right? VirtualBox, or maybe you're running WhatsApp. Okay, so if WhatsApp were a container, okay, so WhatsApp will be running inside a operating system. Okay, which is very lightweight, and it contains only the file system that are required by WhatsApp. Okay, and nothing else. So if you want to run if you say like I want to run if WhatsApp is a containerized application. Okay, it will have its own file system. Okay, if WhatsApp is would be uh, would be a containerized application. Okay, so it will have his own file system. Okay, own process stack, right? It will have its separate libraries. Okay, and it will have its separate, okay, uh, binaries. Okay, separate binaries. So why they are important, like we are talking about why separate process stack, own file system, separate libraries, separate binaries. Okay, why do we need all this thing for a containerized application? Okay, so let's see why these are important. So these are, let's take an example. Okay, so you have an application. Okay, so let's say you're building your, this is your operating system, right? So can you tell me, right, what so if I use a Windows 7 system, right? So what are the important folders in Windows 7? So can you name some of the important folders in Windows 7?
CDE.
C drive, that is a drive, right? C drive is a main drive, right? Main drive. Okay, so D, it may or may not be there. Okay, let's talk about D, right? C drive. So what are the main folders in C drive? What are the main folders in C drive?
Libraries, program files,
Program
administrator,
program files, yes. Program file program files. What else?
administrator.
files.
Administrator. Okay, right. What else? System 32.
Yeah, system 32.
Okay. Have you heard of host file? Host file.
Yeah,
Right. So it contains host to IP mapping, right? So like if you want to reach out to google.com, right? That might have some IP, right? I'm just taking an example. Maybe your website has some IP, okay, and then you want to access this using a name, right? Let's say your website has 142.23.23.23. This is your website IP, okay, posted somewhere. It's a public IP, and you don't want to use IP, okay, so you use some name, right? My website dot local dot com. Okay, so this is your website. So this host file contain this kind of information. Okay, what else? What are other folders or files that are part of your C drive that you can recognize are important? How about users, right? Users, do you consider user as an important folder? Yes.
Yes.
Yes. So we on Windows, when you create a user, there is a user folder gets created, right? Let's say Anto, let's say Anuradha is there, right? Let's say Rohan is there, right? So every user who logs in into the system with his own user has a folder here, right? Okay. I don't want to miss anybody. So Lalit is there, right? Who else? Who is missing? Mahesh. I don't know. Mahesh is a coordinator. I don't know. Let's take Mahesh as a here as well. Okay, Nikhil. Nikhil left. Okay, I don't want to upset Nikhil here. Okay, so everybody is using the system. They are able to log in here. Okay, and they are fine here. Okay, let's say I am the administrator on the system. Okay, I can access all these users. Okay, if you like Nikhil logs in, he cannot see Anto, Anuradha, Roshan, Sandeep, Yash. He cannot see all this folder here. Okay, uh, I am being admin. I can see all this folder because I am the administrator on the system. Okay, so I am the admin on the system. Fine. Okay, so let's say you are deploying an application. Okay, let's say let's say app. There is an application called app1. Okay, and it creates a folder called folder app. Okay, and hash number. Okay, uh, have app and some number. Okay, so let's say it is started on first, and it will create app one. Okay, so like this is the name of the application. Okay, it creates app in users folder. Okay, so if I deploy this application, okay, it will create a folder called app1 in the users folder. Okay, um, and this application, what it does is it deletes all other users on the system. Perfect, right? So all others user on the system it deletes. Okay, so what will happen if I run this application on this machine? Anything? Anybody? If I run this application, if I run this application on the system, what will happen? What will happen if I run this application on the host? Okay, any answer? Like it will delete all these folders, right? If I run this application app1, it will delete folders that are part of the users directory, right? It will only after deleting, it will only have admin, because admin cannot be deleted. It's an administrator user. You cannot delete admin folder, but rest of them are normal users. It will delete them, right? So the only folder that will left is app1 here. Okay, so what is this, like what do we call this, right? So this is called as uh, an application interfering in the file system. Okay, so it is making changes in the file system. Okay, so how do you prevent this kind of issue? Like it's an application that deletes your folders, right? Okay, this kind of behavior is also um, prominent in hacking hackers, right? So the hackers do a lot of this thing. Okay, so how do you prevent this thing? How you want to run application, but you don't want to you need to make sure that it doesn't delete anything on your folder, doesn't make changes on the folder on your host operating system. Okay, so how to prevent this? So it you can prevent this by running into a separate operating system. Okay, and this operating system is gas OS. Okay, so if this application runs here, okay, so you don't need to worry about your host operating system. Your all the folders here will not be affected. Okay, so what did you do here is you separated the file system. Okay, this is called file system separation. Okay, this is called file system separation. So by this means you are making sure your application running will not affect your host operating system. Okay, this way your system will not get any issues. Okay, one of the major problem is when you install a software, it try to install libraries in the program files and system32, right? And you know that Windows have their own files on own DLLs, right? So DLLs are dynamic link libraries in Windows, which are responsible to run your you run your operating system in a smooth manner. Okay, so whenever you install a new application, these dynamic link libraries are replaced by the libraries in the application. Okay, so over the time, when you install multiple application on Windows, these dynamic link libraries are replaced by the application dynamic link libraries. Okay, and that if you install an old application library, it will replace the libraries with the old library, and it will eventually make your Windows slow, right? So that is the main reason your system started to started to feel slow when you install multiple application. Okay, so to reduce all these issues, okay, people came with a concept called gas OS, or so we are not talking about VM. VM is another way to implement gas OS. We are talking about containerization. So they started to build a system which has its own file system, okay, which provides files system separations. Okay, just like file system separation, there is a process separation as well. Okay, so you might have multiple processes running here. Okay, you might have Firefox. Okay, you might have Edge here. You might have Chrome here. You might have uh, Photos application, right? Photos.exe here. Okay, you might be playing a game like Need for Speed here, right? .exe here. So you might be playing a game here. Okay, or you might be doing some chat. So WhatsApp.exe is also running here. Okay, so these are running on your host operating system. Okay, but if you want to run an application, so if you run it in a different, if you run in a separate OS or guest guest OS or container, so it will have a separate process. So in this process, in this here, right, it will only have the program that you will run. So app1, okay, only app1 will be running here. These processes will not be available inside here. Okay, this process will not be available. So because it is running only one application, this application can run very smoothly. Okay, there is no interference in the application. Okay, so it is like you are so running so I take it as a practical example. Okay, if you are running in a joint family, right? So if you live in a joint family, what problem will you face? I live in a joint family, there are no offenses, I live in a joint family. I There are a lot of benefits and there are a lot of issues as well. So can you just give me one or two example where you will one or two issues you will face when you live in a joint family? How about dependencies? Like when you live in a joint family, you will have dependencies, right? Correct. So if you want to go for a picnic, you cannot go alone, right? You cannot take decision very fast, right? Somebody will pull your leg. Just joking. Yeah, so somebody will pull your leg, right? So if you want to go for a picnic, you have to ask everybody, right? Okay, can I go to picnic? Let's go for picnic. Let's plan this. Let's plan that. Let's book a train, right? You cannot. So if it's a big family, you have to book for everyone, right? And booking for everyone is not an easy task, right? You have to plan it properly. So so you should have running your app, so your app cannot run in a bigger environment. Okay, so if you run in a bigger environment, it will face issues. So that is why we deploy application in a separate isolated environment. Okay, and containers provide you an isolated environment. Okay, so containers. Okay, so here we saw this is a container. Okay, so container is just like a guest operating system. Okay, but it need to run, it cannot run direct, you cannot run direct container directly on operating system. So this is your operating system. Okay, this is your host OS. Okay, OS, and you cannot run container directly here, right? This is your container. Okay, container 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 one. Okay, so you might have multiple container. Okay, so container 2, container 3. So you cannot run container directly here, right? So you need some layer here, right? Just like we have hypervisor here, right? So some communication must be there, right? So this should be some platform that gives you ability to run container. Okay, because this piece of software, okay, need to talk to operating system, because container cannot talk to operating system directly. Container will be talking to another agent. Okay, so this is called a, we can call is a runtime. Okay, runtime. Okay, just like in case of in the case of virtual machines, we have hypervisor. In case of container, we have a container runtime. Okay, and this is also called CRI in a short form, container runtime engine. Okay, container runtime engine or container runtime uh, uh, interface. Okay, CRE or CRI. So you will hear a lot of where, so CRI, what is a CRI? So CRI is a container runtime engine that runs a container. Okay, and this CRI is responsible to talk to host operating system to give the required resources to container to run something. Okay, so container cannot run empty, right? It needs some RAM actually. Okay, but it doesn't acquire all the RAM at once. Okay, so this container runtime okay, is there are many container runtime just like VirtualBox and VMware. One of the famous container runtime is Docker. Okay, I missed a C here. Docker. Okay, so Docker is a runtime that provides you ability to manage containers. Okay, so containers containers runs your application. Okay, and who runs your containers is Docker, which runs container. Okay, Docker is a famous container runtime. There are other container runtime like Podman. Okay, okay, and there is another one is Containerd. Okay, these are the three major container runtime available in the Linux in the industry. So most of the time, 70% of the people are using Docker. Okay, and the rest is shared between Podman and Containerd. Okay, so we will focus on Docker. If you learn Docker, rest of the tools are similar. Okay, it manages thing in its own. Okay, so so container runtime is fine, right? And you have a container, okay? So but how do you manage a container? So how do containers start? How do containers stops? What is the life cycle of the container? Okay, so life cycle of container. Okay, okay. So life cycle of container. Okay, so when you first create a container, okay, so this is a container. Okay, so what does it do? So what you do is there is a concept called image. Okay, image or disk, right? So when you so if you have installed operating system in any in your uh, past, right, you need a disk, operating system disk. Okay, so this disk contain the operating system image. Okay, and it contains boot disk, files, libraries, and everything that you need, that is required to run the operating system. Okay, so similar to that, containers also have images. Okay, and these are called container image. Okay, okay, container image. Okay, so the container image can be specific to operating system in system. Okay, like Ubuntu. Ubuntu is Linux operating system, right? CentOS, you will find image for CentOS. You will find image for Windows, right? There is an image called Windows as well. Okay, Windows Core. I'm talking about Windows Core because container are very lightweight. They will not contain GUI, or they will not contain any graphical user interface, like GUI is graphical interface as well. They will not contain any heavyweight application, heavyweight interfaces. Okay, because they are meant to be lightweighted. Okay, Windows Core, Mac OS, right? They have these are the operating system containers. Okay, the containers image can be applications. Okay, like you have WhatsApp as a container, right? WhatsApp. So the when you spin up an image, it will run WhatsApp. Okay, you don't need to install anything. When you start a container using WhatsApp image, it will run WhatsApp. Okay, um, you might have used Python, right? So Python or Node.js or any programming languages. So you can have uh, container image for programming languages like Python, right? Node.js. Okay. You might have used PHP. PHP is again you can have a container of PHP. If you have a PHP application, you can use a PHP container image and you can deploy your application inside that. Okay. We'll see an example of that as well. Okay. So you have application specific container images. You will surely find a Mario image as well. Mario, if you are an old guy like me, like you might have played my Mario game, right? Mario, there will be a container image for Mario as well. Okay, Contra. So I have used Contra uh, game on a container as well. Okay, you will find Minecraft container images. Okay, so these are applications, right? These are application or games that you can build, right? So tools, right? So you will find container image for tools, right? Network images like BusyBox. Okay, so BusyBox is a famous container image which is used for network troubleshooting. Okay. So there are other like Nginx, right? It's a proxy software. If you have used Tomcat, right? You will find a Tomcat container image as well. Okay. What else? So can anyone, so you can, so just try to speak out any tool that you have used or any operating system, anything that you have used. Can you can one of like can you please tell me some tool that you have used in your like work workspace or anything, any tool that you have used? Can you guys like girls and like tell me tools name that you have used, and I will try to see if there is a container image for that. How about VS Code? Have you used VS Code? Yes, Nikhil, you are trying to speak and something.
Yes, sir. VS Code.
V VS Code have a Docker image. You can run VS Code in container. What else? Anto. So have you used any tools or anything? You can name anything, any software or any platform that you have used that comes to your mind.
Redis.
Redis, yeah, Redis. Redis is a database, right? Memcached. Sorry, it's a, I don't know. It's a database actually. It's a
DB.
Redis. It's a cached database. Yep, we have a Docker image for Redis as well. I use Redis a lot. How about Lalit? Lalit, have you used uh, any tool? Any tool you can name?
Yeah, no, I sort of I didn't use any tool.
Anything. When you open laptop, what is the first thing you open? First thing that you start a laptop, what is the first thing you open?
The first thing I'll use my file managers.
Exactly. I don't know if there's a file manager disk. Okay, no, file manager is not an it's a inbuilt onto operating system. Anything else like Firefox, right? You use Firefox, right? So Firefox also have an image. Like believe me. So Firefox can you can also run Firefox in a container. Okay. So yeah, Yashwini, you're
Microsoft
saying anything?
Teams, Cloud9.
Cloud9?
Yes, Microsoft Teams and Cloud.
Oh, what is Cloud9?
I just had been through it. One of my cousins, she used it. It's a tool.
Cloud9.
Yes,
Okay.
and
I'm sure
Microsoft.
there will be a image for Cloud9. Is it like Cloud9? Did I spell
Yes,
right?
yes.
Yeah, you see, we have a Cloud9 Docker image as well. See here. It's a Linux server, I guess. This is Cloud9. I'm yeah, Linux server Cloud9. It's a Cloud9 Linux server. Okay. So bottom line, whatever tool you are using, whatever framework you are using, there is a container image for that. Okay. So you will definitely find a container image for that. And okay, so like it's almost a time. So so what does this mean is, so you can use container in for anything. Okay, you can deploy your application in container. Okay, you can play games in container. You can explore different operating systems using containers. Okay, and you can scale. Okay, so one thing is it right? So if you see this Cloud9 image, right? So what is the size of this Cloud9 image? Okay, if I open tags here, okay, so you see, right, this is one of the image. Okay, this is one of the image. It's like this is made for Linux AMD 64. This is for ARM v7, and this is for ARM v8, right? So you see the size of operating system, 300 MB, right? So what is the size of Windows operating system? Like you buy a disk or you download a ISO. What is the size of Windows operating system? Okay. Let's say Windows 11 ISO, right? If I see this, right? Okay. So it will say something GB, right? I don't know. Oh, say GB. Okay, at least 8 GB, right? So a blank DVD disk with 8 GB. So it requires 8 gigs of disk space, right? The ISO image is 8 GB. Here the whole operating system is 304 MB. So consider the size of the container you will be running, right? So the containers spins in 1 second or 2 seconds. Okay. So your application are up in 1 second or 2 seconds or at least 3 seconds. Okay. At most. So that is the container speed, right? So we'll see in the next slide why they are so why there is so buzz about the containers. Okay, let's finish up the life cycle, right? So you create from image, you create a container. Okay, so how do you create a container? Using docker run command. Okay, so when you fire a docker run command, okay, so let's say I want to start Ubuntu. Okay, so I say Ubuntu. Okay, and I just say minus image docker and Ubuntu, just docker and Ubuntu. So what it does is it creates a container from Ubuntu image. Okay, so when the container is created, okay, this is called start. This is called a running state. Okay, running state. Okay, this state is called from this to this. Okay, it is called creating. Okay, this is called creating state, right? And there is a container here. So this to this is called running state, right? Okay, this is called running state. Okay, all right. So this is called running state. Okay, so after running, okay, so it can be either stopped, okay, or it can be killed. Okay, so once you are done with your container, you are okay with your testing or your application is finished. You might be running some download or you might be running some backup. Okay, you are finished with your work. You can stop it. Okay, so container will be in the stop state. Okay, so this state is called stopped state. Stopped state, right? Okay, so the container, the other thing is container can be removed, okay, directly. So when it is running and you don't want this container, like maybe by mistake you spinned up, you can remove it. Okay, remove it. So once you remove the container, okay, the container is dead. Okay, you cannot bring it back. Okay, but when the container is stopped, you can again bring it to start. Okay. Okay, so this is called container life cycle. Okay, so you create a container from an image. Okay, the container is running now. Okay, so from running container you can stop it, you can remove it. Okay, and a stop container can be started again. Okay, and the same container will continue on. Okay, and there are other operation as well, and we'll see this operation tomorrow. Okay, uh, so I'll just stop here and we'll take questions from any of the doubt you have from the today's session. So I'll just stop it here. Do we have any question from today's session?
Hi Prakash.
Yep. Yep.
Actually, I have a small suggestion.
Yep. Please.
I think we had a lag of 1 week classes, right?
No, we didn't had any classes in between.
Previously, previous week we didn't conduct any classes.
Yeah, previous week only Jenkins was there 1 day.
Yes, only one class is conducted. When is the syllabus is going to complete?
By end of June, like by end of June we will finish. So
Yeah, yeah, yeah.
we have
That's
three.
what I am a
Yeah.
little bit worried about. If you want, you can increase the class timings for about 1.5 hour. So that's my small suggestion.
Okay, okay, so I'll show you the timeline. So we have started containers today. Okay, so for
Okay.
next 5 days we will do containerized technology, container technologies. Okay.
Okay.
And for one day, we will do a hands-on only. Okay. So it will be like we will learn Docker, okay, and Kubernetes basics. Okay, Kubernetes. So and one day we will have a project, a hands-on project. Okay, hands-on. So this hands-on will be based. So I'll just show you what to do. Okay, you do it on your own system, and if there is any doubt, we'll cover up. Okay, so this will be based on containers and Kubernetes only. Okay, and I will be try to finish this by 13th June. Okay, so containers will finish on 13th, and the next 5 days. Okay, this will be like from 15th to like what is the timeline? So next 5 days, like 15th, or it will be like 13th, right? So 13th and 14th, right? So not this. Okay, from 13 to 22. Okay, we will have AWS, okay, and monitoring. So these are the left. So we are targeting 22, but in worst case, we are saying end of the June. Like we are targeting 22 will be the last day of the class. Okay.
So, from today onwards, are you going to take our classes regularly?
Yeah, from today onward, I'll take class regularly.
Okay. What about